in our TQS as well, because you're developing that understanding with students, and it takes more than 1 or 2 or 3 lessons to do that. So we're all working in this curriculum together and learning this curriculum together. So I'm going to use the wisdom of Maya Angelou to frame this, is that we're doing the best we can until we know better. And then when we know better, we do better. So the key ideas that I want you to walk away with today is that the scientific methods are meant to be integrated into all other organizing ideas. Secondly, they're the way in which students should be building knowledge in each organizing idea. And if you're in my sessions before, I talked a lot about explore before explain, or investigate first, then explain, and we'll work through that a little, remind ourselves today. The focus of teacher clarity. So taking the time, and kudos to you for coming live today or watching from home, to unpack the curriculum empowers you to choose activities or resources that truly align with the curriculum. And from that, we're going to look at developing a sequence from the curriculum to map out where our students are going and how they're going to get there. And so, of course, you're going to receive the planning guide for which you could use going forward. So if we go to our curriculum subject introduction, it states, the science curriculum engages students in active investigation to build scientific knowledge. So we're going to talk about what that means a little bit and get into that, as well as developing critical thinking and problem solving skills, because the scientific methods are meant to be, if they add robustness, they make it more of a thinking, they're the thinking skills of the science processes. And that students have opportunities to integrate these into all other areas of the curriculum. Not only does it state that, if we go to the learning outcomes and all other organizing ideas, it states students investigate. So what was developed for you, which is connected to the planning resource document you'll receive, is a science verb glossary. And this science verb glossary sort of looks at the skills in both the learning outcomes as well as the skills and procedures. So investigate says to use a process of inquiry to gain deeper understanding. That process or procedure was laid out in the grade 2 knowledge statement in the year prior. So these are the processes or steps that students go through to build knowledge. And if you're in the summer symposium, you know that I had developed this graphic organizer to kind of help us know that it's not sort of step by step, but it's a circular, cyclical process that students will go through a lot. So when I mention explore before explain, which is how this unit will unfold or is developed, the students go through this process of making predictions, observing, analyzing the data to get some information from it, and reach conclusions. Well, they need to do that first before being given, and there's a number of reasons. We're going to get into vocabulary and developmental appropriateness, but they need to do that first before given the terminology. But they can't just sort of, I think this. They should confirm their conclusions with video, text, or what does the science community say? That's usually what I would say to my students. Let's find out and see if they can synthesize that information. So kind of summing up, I saw Peter Lillenhall, and he wrote Building Thinking Classrooms in Mathematics, and math and science are very similar. And he stated that learning truly sticks when students engage in hands-on math or science investigations. Names of concepts or science ideas should come after experiences with those ideas. So we want that explore, that experience first, investigating first. Another clue, not only in our learning outcome does it say investigate, but if you look at the skills and procedures, you're going to see things like predict, test, explore. Explore isn't just going off and finding out. They can use an informal investigation. They can still use the steps from the skills, from the scientific methods that I had indicated. Observe, investigate, and examine. But I want to focus in on the specific CUSPA that I chose to do in a sample with in grade 3, which is, the forces can affect properties and movement of objects. These two skills and procedures say conduct investigations. How is conducting an investigation different than investigate? Well, if you look at our verb glossary, conduct means to engage in the process of planning and carrying out um, an investigation. So you can see in our cycle here that students are expected to be involved in the planning process. So if you happen to use the unit that I did for the ice cream unit, you know that students were involved in the planning process, especially with reversible and reversible changes in matter. So in conducting means they're really going to have to be involved in that planning process. So the document that you receive is for the planning guide. This is the title page, and it's a PDF, and this PDF is linked. So you can use it digitally or print it off if you choose. And so basically it describes what to do here, and then there's guiding questions, and then the sample of energy is in the middle. We're going to unpack that today. And on the side is a toolbox, and that toolbox has linked resources. So it has the science verb glossary, depending on the stage of the planning process that I have referred to. ARPDC is putting forward, and some of you may or may not be aware, is the CPAR, Curriculum Planning and Assessment Resource Document. That's going to have a lot of links to different resources that you guys are looking for. CMAST, which is the Center of Mathematics and Science Technology Education at the University of Alberta, has a wonderful site. They're putting resources together for you, but it's in process, so you do need to check back. The sample planner guide that you're going to receive today, as well as a blank planner template. So this guide wasn't sort of just something out of my head. It was based on review of literature and best practices for planning. And so we have our tried and true understanding by design, or keeping the end in mind, as we hear from Wiggins and McTighe. But not only that is teacher clarity. And that came out of John Hattie's meta-analysis, that if teachers have clarity and understanding, that impacts is over a year's worth of growth, and as if our students are clear as well. But we as educators need to be clear first before students. And then hot off the press that came out in December was a report by the Education Endowment Foundation. And in the United Kingdom, they did an international scan of best practices in science, in primary science. So all of that has informed what you're going to hear about today. So beginning with focusing on clarity starts with us unpacking the curriculum. And I know we feel that we kind of know, I know it's forces, but it might be looking at it in a different way, because we want to be thinking about our students developmentally and where they're at and how old they are and how we should be sequencing. They're going on a learning journey with us from beginning, middle to end. And how are we sort of helping guide them along the way? And it starts with our curriculum. So the first step, we're going to unpack this resource guide here and go through some samples. The first step is we need to analyze the learning outcomes to identify the skills and concepts which direct the how and what of our summative assessment. We know that. We know that the learning outcome is what we summatively assess. What I have attached is the scientific method learning outcome, because every unit, every organizing idea, they're building knowledge through investigation. That scientific methods is integrated. So let's look at our guiding questions. It says, what concepts, nouns, or science ideas will students need to learn? So I've underlined here forces and movement of objects. So there's a relationship there. And then if we go to the scientific methods, it's investigation, which has started in grade 1. Foundationally, grade 2 kind of went into purpose of an investigation, and we still think about that in grade 3. But then we add to and look at its connection to building knowledge. So then we look at the skills and those verbs, because we need to be clear on what that means for assessment, because that's how students use to demonstrate and what they know, understand, and can do. So it's all through investigation, and they investigate in order to explain how forces affect the movement. And if we look at our verb glossary, explain is very important in science because science is always asking why or looking for reasons or causes for things. So what's causing movement, right? So something to do with forces. And then relate, we know, means a connection. So now that we know the learning outcome, which is a very broad statement as we know, then we know that the cusps kind of break it down. So we need to examine the cusps in order to identify those science concepts and skills that the students are going to demonstrate, and we're going to formatively assess. So we know that we formatively assess the cusps. So what I've done here is if we go to our guiding question, what concepts, nouns or science ideas in the knowledge and understanding statements are integral to student understanding? So I'm going to just show the screens a little bit clearer. So what I've done is I've color coded the science ideas. Okay, so you can see forces, properties, movement, and objects. Okay, so in here, I've started to move the skills and procedures around. And you're going to see some changes when we sequence. But for now, I'm unpacking this and kind of getting into this deeper. What does it mean? So we know that a force is a push or a pull. Okay, and so our students are going to need to know that. And that an object that stays still will not move until a force makes it move, and it won't stop until a force makes it stop. Okay, so then the type of forces, there's not many, but there's a few different types of forces. And so we zero in grade 3, and the students need to know contact force. And then that's defined in when it says include, that means that this is what they're learning, that it's applied by a person or another object, that objects are, surfaces are gliding or sliding over each other. And in parenthesis, that's friction. Applied by pulling a string or rope, and parenthesis is tension. We're going to talk about the parenthesis. And it's caused by compression, which is pushing together, or stretching, which is pulling apart. And so what I'd like you to do, this isn't very intense or anything, and if you don't have access to a chat, that's fine, but I'm going to pause for 1 or 2 minutes. And what I'd like you to do is I'd like you to look at the skills and tell me, what verbs should I be circling for or focusing on in terms of formative assessment? So what are the verbs that are important that our students need to do in this knowledge statement? You can just list the words. I gave you a hint. There's 8 circles. So there's 8 verbs in the skill area. So if you could just drop in the chat, you can just drop a list. Our grade 2 colleagues did that the other day. Nice, Taylor. Okay, focus on skills here. In the skills area, what are the verbs in the skills area that we're zeroing in on? Okay, not the knowledge statement, just the skills. What the students need to do, they need to describe, right, Jenny, they need to predict, describe. Yes, you guys got it. Compare, nice, conduct. Right on, okay, you guys got it. Good work, you guys. So yes, that's what they're doing. They're going to conduct an investigation. We talked about what conduct means. But when you do an investigation, you're doing it for a purpose, to demonstrate. That's the verb. And we're going to talk about that. And predict, describe, compare, and again, conducting an investigation to demonstrate about forces changing properties. So demonstrate, because conducting an investigation is probably going to be the overarching piece of what the students need to do here. Then we need to know that students demonstrate means that they show or express an understanding through their actions. So they're going to show or demonstrate when they investigate how the forces affect movement, how forces change the shape or size of an object. So if we look at, you guys are picking out describe, which is great. During their investigations, while they're demonstrating through action, they're going to describe the strength and direction of the forces applied to objects. So when she was hitting it or pushing the ball, They're going to be able to use, and it was, defined here. So the strength is given to us. The students will use strong, weak, large, or small to describe it. In the direction, they're going to use upward, downward, from left, from the right, from both sides, from all directions. Okay, and somebody said compare as well, and that we know means to consider similarities. So they're also predicting, which you guys have also pointed out, and we know that means it's a likely answer. So, or usually that's the grade 1 definition. In science, a prediction is an anticipation of what you're going to observe. So they're going to anticipate how objects will be affected by the different strengths and directions of the force during their investigation. So I mentioned that I wanted to talk to you about parenthesis. Many of us know that the parenthesis is for the teacher. So I want to provide clarity in that. I had some training from Alberta Education, and I brought up that question for a reason because of some resources that I've been seeing out there. I asked the question and I said, well, what if we do teach, Newton's first law, or because I have seen videos or articles connected to our curriculum that students are supposed to read for that, or friction or tension. And the response I received was, if we do that, we're going off the curriculum. And there's a reason for that, for developmental appropriateness, especially because a law in science, like, what does that mean? It's more important about the idea behind it than it is about those terminologies, especially because they're demonstrating and describing the strength applied. It's not like they have to know it's tension force or it's elastic force. Okay, so I want you, this is the last time I'm going to ask you, but I need your just a little bit of help here. Let's look at the skills and procedures here, and we're going to think about resources that we can pull up Pinterest or, or anything like that, or Teachers Pay Teachers. Let's think of this. Conduct an investigation to demonstrate, so we know that means through action, how an applied force by pulling on a string or rope is connected to an object affects its movement. So I want you to consider which learning engagement allows students to best meet that skill and procedure, because that's what students are doing, right? That we're formatively assessing. So we have number 1 over here, and then we have number 2. So they'll look at the pictures and they're sorting from tension, elastic, or friction. So please drop in the chat. I'm just going to pause for a moment. Which do you think, number 1 or number 2? Right. That's an act through action, and they'll describe using words that were given in our curriculum. So when it comes to resources, we have to remember that resources are tools in your toolbox. A resource will never fully align to the curriculum. It will help support you deliver the curriculum, but it is not the curriculum. So it's important that we take time to understand the curriculum so that we can pick the right tool in what we're trying to achieve with our students. Okay, so now that we know what our curriculum is asking and the science ideas that our students are working with, then what we want to do when we're thinking about this is connect those science ideas from the curriculum to foundational science ideas. In order to determine essential science ideas for our own clarity, to make sure that we have an understanding to enhance student learning, as well as to determine potential student misconceptions that might interfere with their learning or interfere with assessment. So the questions we consider during this phase is, what terms or science ideas do I understand? And what do I need to learn more about or refresh my memory? Okay. It's been a while. Since high school, I've learned about tension force, or I can't even remember. So, it's looking that up. What concepts in this learning outcomes are connected to the previous grade? Because I have a bridge review lesson for that. What do I need to keep in mind for planning instruction for misconceptions? And we'll talk about that, as well as we're going to talk about the research connected to science vocabulary. So what science vocabulary might be used in a non-science context, an everyday way that might potentially confuse students, and we're going to talk about that. So I mentioned the previous grades learning because this curriculum is different. It's spiraling and there's foundational ideas that pull through from year to year. So in kindergarten, they start looking at what is movement. And I'm distilled this down to an essence, right? So movement is the change of location and position. In grade one, they start to describe movement, and this actually is very critical for grade three, for what we're going to be doing in terms of how it affects movement. So movement consists of speed and direction and a pathway. Might appear like grade two goes off in a different tangent, but travel indicates how does light and sound travel. There's a bit of movement there. The contact forces affecting movement. And also considering in grade three, what you're teaching this year is actually foundational to the remainder of energy organizing idea for 4 to 6. Just going to briefly touch on that because in grade four, as you know, they go through non-contact forces. So they need to know what a force is in grade three and learn those foundational ideas of push and pull and then grade 5 continues on with, flight and opposing forces and buoyancy and gravity. So they're really still working with forces all the way through. So now we're going to connect it to the science ideas, but I just want to pull out such an importance with misconceptions in science. Sometimes there is, a sort of belief that, elementary science is sort of just common sense, but we have to remember that our students are the ages they are. I think in grade three, they're 8 or 9. And their vocabulary is developing, their ideas about the world around them is developing. So they can develop misconceptions and they have ideas about the way the world works. And some of that interferes as well. So having an understanding helps us be aware of how to mitigate or break down some of these misconceptions and work around them. So in your planning document, I just want to point out in your toolbox, I have linked to some sites here. Explorify is an amazing site. And it's not just for misconceptions. They've got some great science lesson ideas. They have something called Tackle the Tricky Bits. And I pulled a lot of that for today's session. CMAST is also putting that together. They're sharing out potential misconceptions. It's just keep checking back. NSTA.org, National Science Teaching Association, you don't need to pay for it. You can access the articles for free, and Paige Keeley has some wonderful formative assessment probes. Okay, so we know that forces are pushes and pulls. And we can't see a force, but we see their effects. We see the effects in when an object changes its movement or shape, that's the effect. We know that a force is acting on it. When two objects or people are touching, it's called a contact force. All right. So I know that it says, in everyday life. So, I know there's games and sports and lots of different things that we can bring in to connect with. But what I wanted to point out today is the connection of forces, matter and forces, and it was confirmed in the literature I was reading, it is really wonderful to connect these physical sciences ideas to other science disciplines like earth systems, right? Because they're looking at in grade three, investigating the changes to the earth's surface over time, like weathering and erosion and glaciers. And all of those connect back to forces, our forces in nature. And if they have that solid understanding first, they're going to make a deeper connection when we get to those organizing ideas. Okay, so in the knowledge statement, it says that an object is not moving and it stays still until an object acts on it. That is common sense, because if an object moves by itself, that's a little eerie and we get a little creeped out by that. But how that works though, is there are forces acting on, if this basketball is staying still, like you sitting in the chair watching this, there's gravity, of course, obviously, but the chair is pushing back are pulling you up and the ground. So there's forces all around us on Earth at all times. However, if there's a stronger force coming in one direction from the side, this basketball will then start moving. But what children sometimes have is that a misconception is that only people have the power to move things. So objects move when only people push or pull them. But when any two objects interact through a direct or indirect contact, direct is grade 3, then we know that there's a force. So the sandwich, as I mentioned, you sitting in that chair, the sandwich on the plate, both are exerting forces on each other. So when you're doing investigations with students, not only having them push or pull, but having them move an object and seeing when that object hits another object, what that interaction is to counter that. Another misconception that came out was that students often think that if an object is moving, a force must be acting on it. Motion implies force. Or a force there's some kind of force that's keeping that tennis ball floating in the air. Forces just cause changes in motion. If an object is moving, no force is necessary to keep it moving, but a force is needed to make it stop or change direction or move. So this is where students come with an understanding that yes, this object that stays still isn't going to move until a force acts on it. But if you think about in outer space, there is no force. So you would float away and around and you keep moving. If you needed to change direction and you're out there, you have your little thrusters that move you or change the direction. Another misconception for our students is that all objects slow down and eventually stop. And I just mentioned, like, within the absence of force in space, we would just keep moving forever. So if no forces are acting on it, they'll keep going and they won't stop. Another misconception is that forces get things going and don't stop things. An object stops because it runs out of force or energy. Objects don't contain force, like when we think of energy. They can't run out of it. All that forces are is an interaction, a push, pull, a touch, a tug, or a twist between two objects. Connected to that idea is sometimes the misconception is that force can transfer from one object to another, kind of like that Rube Goldberg machine that we used to see out and bring in all the time. That connected to our old curriculum for the energy was in there, but that's confusing force with energy. Force describes, as I mentioned, it's an interaction. Force describes that interaction between two objects that we see the movement or changes in movement and shape. So what I want to highlight here is avoid at all costs bringing up energy because it really isn't part of our curriculum in elementary. It will be later on, but it's not at all. And if you go into any of the learning outcomes or skills and procedures, it's not mentioned. It's an abstract concept that is very challenging and a lot of misconceptions can come up. So we don't want to confuse our students with that either. So I mentioned that an object will keep moving until another force acts on it. Well, that other force is friction. So to slow down or stop moving, another force acts on it. So if you think of the soccer ball rolling, the grass is going in the other, kind of like that sliding in the other direction, but it's caused by the bumps on both surfaces. And there's kind of a lesson, some idea lessons that I have around investigation around that. And that friction occurs when two objects rub or roll or slide against each other. Connected to the second cusp about simple machines, when it talks in your skills and procedures about you need a greater amount of effort, please keep using effort. Don't use work because that confuses students. But simple machines are overcome the force of friction. That's really what a simple machine does. It makes it easier to do things because less friction is involved. So how do we help with some of these misconceptions? So it's in the literature, it's saying, look, it's not possible. Like, if you just tell them about it, that's not going to help. So in forces, because there's so many potential misconceptions, the advice is to give a lot of hands-on investigations in different ways and in the different tips that I mentioned. Predict, observe, explain. That's the scientific methods. They kept saying, have students predict possible outcomes and then be confronted by some of their thinking about that and think about why, right? Why is this happening? And just keep in mind an awareness of the language you use. So for example, we might be tempted to ask something like this. The ball is sitting on the table. There's no force acting on it. But when we kick the ball, what force is acting on it? that question implies that the ball at rest has no forces. And so we want to see something like the ball is not moving. So let's keep force out of that one. When we kick the ball, what force is acting on the ball? So I mentioned about science vocabulary and some of the research behind that. Well, what came out of that report, and this is something I was aware of, and is I learned a big word, polysemious words. And what really that means is words that have everyday meaning, a different meaning, and then a science meaning. And students will come in, for example, force. So if we started playing a video, we're going to learn about forces today. Sometimes their knowledge of force is, I'm forcing you to do something. And we know in science that means a push or pull. Okay. Theory is one that most even adults have a misunderstanding about. Like they think of theory as just an idea, when actually in science it's substantiated with an amount of evidence that indicates an idea. So when teaching, what they were talking about is the different tiers. And I know that kind of connects to ELAL in our vocabulary, because it does mention that in the vocabulary skills and procedures. What about force as a twist? Excellent, excellent, love it. Yes, twist is the new thing. Thanks, Lorraine. Absolutely. It's not in our curriculum, doesn't harm, doesn't hurt to bring that up as well. So the tier 1 are push or pull. So we want to make sure we know about these polysemious words. And we want to know about tier 2 that goes across the curriculum. And tier 3 is, like force, contact force, those kinds of things we want to make sure our students know about. Yay, Star Wars Force. I was going to actually have a little of that. So what you want to have is a word wall, or, and this is co-constructed with students or with visuals or pictures, because that really helps all learners. But what I want to make you aware of in grade 3 is we are preparing them for upper elementary. And I used to have my students have glossaries and refer back to him, not just put it in there and put it away and forget about it. And so it kind of provided a little kind of outline from Marzano's 6 steps is, provide a description, but get them to think, pair, share, put the term in their own student-friendly language, maybe in a partner's or whatever, and then do a quick sketch, and they can kind of do a sentence that connects with it. All right, so now that we've, pulled the science ideas, what are my science students working with? We've connected that, what could be potential misconceptions? We're ready to start planning. So in this particular phase, and I will show this was a screenshot, so I'm going to show the next slide, we'll have a clearer image. But basically the guiding question is, how will the concepts and skills be combined and sequenced? So currently in our curriculum, they've separated it out. But what we want to do is bring it back together and then put it in an order that makes sense to unfold for our students as in a unit. And I started you off on that, so no worries. And then think about, where do you want students to have the opportunities to practice the steps in the investigation cycle or the skills from the scientific methods? So now we're going to bring in those scientific methods as well. And this is where the sample plan is linked, and the blank planner template if you move forward. Okay, so I'm going to walk through the resource you will receive today that you're waiting for. So this is the sample unit plan. So it's a start of the unit plan. So what you're going to get is a table of contents so you can find everything. And it's a little different than scientific methods because it's just getting you started. So that sequencing has been done. And then when we bring in the scientific methods, here are the resources linked for Explore, which would be like your investigation or where students are kind of working through the ideas. And then the Explain phase, and that's where I bring in the books and the videos that help enhance to do after. And then you can see here I've got the scientific methods, but we are going to talk about summative task. I have a summative task with a rubric. And I got you started with 2 series of lessons. So as you can see, their lessons are more than 1 day. So and then you can continue planning on after that. So I get you kind of started, and then you can continue after that. All right, let's see if I can get onto the next page here. All right. So as I mentioned, what you want to do is combine the knowledge statement and the skills and procedures. So we went through the cusps. Again, these are not lesson plans. We're just thinking about how I'm going to order those ideas. So we know our students are expected to conduct an investigation to demonstrate the effects of forces on an object that is staying still. So they're going to start with that. It makes sense to start with that before talking about friction, right? And then through that investigation, they're going to, work with different objects, to getting them going. They're going to describe the strength, and I've listed that there. They're going to predict the effect of those strengths or directions, and they're describing the direction as well. Then they're going to conduct the investigation to demonstrate the effects of forces with the surfaces on each other. So they don't need to know the term friction, but I do kind of introduce that here. And then again, the same things as above. So they're looking at the strength, describing the strength and the direction of applying that force. Then they go through, you saw that little investigation with the Lego blocks. They're going to conduct an investigation to demonstrate the effects of the contact forces applied by pulling a string. And you can add to those kinds of hands-on with real life experiences in the gym, pulling things with a string as opposed to, pulling by hand, which is a little bit easier. And then finally ending off with conducting an investigation with changing the properties of an object, the shape and the size is the properties that are being changed. So as I mentioned so you can see I've started to go, okay, now I know, like I'm really clear. I know where I can go now, what it is I need to focus on to get for my students or the students, the investigation. So I start linking that in. Some investigation ideas were linked in for you. And then, as I mentioned, some videos. And then because the science methods are the way in which they're building knowledge, I'm always bringing those in. I might not bring it in as much if they're not doing a full-blown conducting investigation. If they're exploring, I usually might do a predict, explain, explore, explain, right? So, or observe, explain. So they might predict, of course, they always have to explain when they make a prediction. They go off and observe, and then they explain that. So I might bring it in informally in the other organizing ideas that don't have conduct, but we're always integrating that throughout. Okay, so as I mentioned, then you're ready, kind of know where I'm going with my students. What are the ideas? So you can, determine evidence of success to, what will students, how will they demonstrate what they know, understand, and are able to put into action in an unfamiliar or real life context as a result of learning in this unit. So this is where the summative piece comes in. So the questions, or the guiding question, is how will students, and I take the verb, which is investigate and explain how forces affect the movement of objects. Okay, so I'm focusing on movement here, as I mentioned. I didn't develop because we're doing so much with movement and friction and things like that, that I didn't do one for properties. So you can kind of develop that as well. And then we're always thinking about assessing summatively. Pieces are focusing on aspects of the scientific methods. So in the one that we did, I focused on collecting data, using technologies to improve the accuracy of, using techniques to improve the accuracy of data collected. So I really focused a lot on that during this, and you're going to see that in some of the ideas that I provide for the links as well. So the performance task that the students are used, and they're going to actually use this to launch the unit, is how can we use force to start movement, but also change the direction and speed to move a ball around opposing players to score a goal. So the criteria is that they use force to get a motionless ball to start moving and direct the applied force to the ball so that it moves around the players to score a goal. It's a plan first. So you'll see it. Students collaboratively plan, test, adjust their plans, and retest scoring that leads to their final selection of the best plan or solution. So where you're going to do a summative assessment is on their independently, students will be assessed on their diagrams and explanations of their final solutions using the single point rubric. So here, students collaboratively plan and test. So you can see they've got their little models up, and they're like going to be, planning it out, testing it. And I've given you a plan to help if you need. They can use ramps for speed, but they're trying to get it around and to score a goal. Okay, so then what you're going to summatively assess is, can they use the words? And I mentioned arrows, like diagram, because we're teaching, I have a whole lesson on how students can use arrows so that they understand how to draw a diagram in science and also how to read it, because that's actually what scientists use a lot. So use words and arrows to describe the strength and direction of the forces applied to the ball, and then they can show the movement on path here. So this was a kindergarten classroom. I had to bump it up because we're in grade 3. They can do a little bit more. All right, so this is the summative rubric that you will receive. And so what's in pink is the energy organizing idea, and the skills are listed up here, and then the criteria for that underneath. So for example, they might say, I predict if we kick the ball from the left towards the wall is their little wooden block, it will move around the bears and into the goal, because when we played, like, a sport or whatever, and then they talk about their investigation. Describing, so we are going to be working on that and reinforcing that throughout the lessons, and then compare the strengths of the forces applied. So as I mentioned, the collecting data using techniques to improve the accuracy by choosing appropriate tools, using a ruler to help draw the arrows, correctly labeling the arrows, teaching them those kinds of skills. I did connect the computer science skill, create a set of instructions that could be followed by human or machine to complete a task. And I thought that would be a great idea, because when scientists record observations, it's for them to reflect back on or understand, but actually the diagrams and things are used to for communication, so that others can understand. So they will write a series of how to score a goal the way that their plan says to, but they can enhance it with their diagram as well. So now that we kind of know all of this, we're ready now to do lesson planning. So we can plan for instruction that is cohesive from the student's perspective, and be strategic in sequencing those lessons that builds on prior knowledge of learning, as well as having the potential to extend student thinking. So I really liked this graphic organizer because, we have 3 teachers in the classroom. You have you, we have our walls that the students can use, and the students have each other. So we have to remember about those think, pair, shares, and really helping each other and using that language. So in this session, or part of the planning process, when you're going to plan off your lesson ideas, you think about what underlying prior knowledge do students need to have from previous grades. So we talked about movement. And how can I minimize those potential misconceptions that we talked about? And how am I going to continue to make sure in my lessons that students are investigating first, and then going off and into synthesizing what they've learned or their conclusions that they draw with what the science community says through video and text? Where can I integrate cross-curricular connections? So I touched briefly on ELAL. So for example, like the vocabulary organizing idea. There's a lot of think, pair, shares, or whole class discussions, so that oral language piece. Or if they're reading text, that comprehension piece. So thinking about bringing in those skills and procedures, and then perhaps adding 15 minutes of your minutes from those areas, because you are bringing it into science, adds and makes your science lesson more robust. And for sure, for formative assessment, what do I want to see my students do? And what do I want to hear my students say during the lessons that helps me know if they're reaching those skills and procedures formatively? Now, I want to point out that I've linked in some instructional strategies, because I don't have the time today to go through all of the strategies that I'll be highlighting, but there are some videos, for example, on learning summary tables, so you can see a teacher introduce it and use it with students. So it's there linked for you if you need. Okay, so the sample lessons that you're going to receive are the bridge review lesson on movement. So that's about, I think it's 2 days. and then the investigation on how objects start moving, that whole conducting an investigation that an object stays still. I fleshed that out. I think you have about 5 days worth of lessons in that one. So you've got some lessons to start you off with. And then as I showed you in the progressions, when I kind of aligned the science methods, you have some investigation ideas. They are not lesson plans. Those are just kind of the procedures of how to do the investigation. So you'll have to develop a lesson around that, and also with the explain as well with the videos, as I mentioned. So the lesson template is a little different than if you use the one in September, because the one in September was more of an alignment or an adaptation. This one is, I've put formative assessment at the top with the skills and procedure. This is the review lesson, so it doesn't quite have it, but I'm still thinking about what do my assessment look for us? So, for example, in the bridges, define movement and describe where movement is happening. And then, of course, we're formatively assessing a little bit of those scientific methods along the way. This green column is the actual lessons. Now, of course, I'm very detailed because I'm communicating to you and trying to help you understand my thinking. I'm sure you're not going to be as detailed, but I'm thinking, in essence, we're thinking, what are they going to do? Why are we doing that? And how will they go about doing it? Also is inclusion and thinking about all the learners in our classroom. So what I usually do in my lessons, I like pull out the vocabulary and I provide some sentence stems, because we should be, for discussion, and that's really good practice, have those posted. And then of course I list the resources. So this particular quote, I think, I hope this gets out to you what we're trying to get at about investigating first too, is that it really isn't about you explaining to your students what the science idea is. It's about creating a learning environment in which they, the students, can construct the explanation and come to that conclusion. So I'm going to walk through some of the sample lessons. We have some time here to do that. So the bridge lesson is, what is movement, as I mentioned. And when we're formatively assessed, just keeping that triangulation of evidence. We don't need to always have a product or a quiz. We can observe our students with what we see and hear what they have to say. So in the first part is kind of an explore. My colleague Ted creates these concept attainments, and I like them. So what I'm just gonna quickly kind of show you, and that's linked in the plan as well, and the directions are here for you. But basically what it is they look at a set of pictures. There's a yes example of movement and a non-example of movement. And you think, okay, so what is movement? So they'll look at the yes examples and the no, and they'll kind of come up with a definition. They'll confirm that definition. Movement is when something changes its location. But that's not all movement is. There's other ways of moving too. So these are the yes examples. These are the no examples. They can add to that. And now it's also a change in position. And there's more activities that kind of build on that. So you can use that with the students to kind of give that bridge. Then what I like to do, because movement is so foundational of a concept to, I'm struggling with this, sorry. Canva, I love you, but sometimes you drive me nuts. Okay. Is I liked, for foundational concepts, I like to do Frayer models. And in grade 3, I think I'll do it once as a class, and then I think the students can do it in partners after that with certain concepts, not all of them, and then put it in their glossaries as well. So we've come up with a definition. They help me craft it, but we have to, in a Frayer model, the characteristics are, how can we describe this word movement? Okay, so movement is a change in location and position, but how can we describe movement? And this is the vocabulary you're providing that they've missed, or, that probably down the line you're going to have to review anyways. Well, let's read to learn. Let's find out. So we have a, book that we're going to read, and I have the pages listed. I just read those pages. On Get Epic, it's free. What is motion? And it talks about direction, and, then you can list the different ones from they can give you what they hear, what they pulled from the book. But that's not all. I have a 2 or 3 minute video that adds a nice sort of like enhances the definition, and it gives more like speed and fast and slow. And then they can go off and do examples and non-examples of movement. So they're clear, because that's what they're zeroing in on, because that's what happens when a force occurs, is the movement, change in movement. So day 2, what they're going to do is they're going to go off and go out into the playground, or look at, with the recess equipment, or you can take to the gymnasium if the weather's not great. But they're going to predict the things that they're going and describe the things that they see move. So when they go to the playground, I have these graphic organizers. You can use them, or if you prefer to use a journal, that's great. You can just use the graphic organizer for some ideas. That's your call. But basically, they'll just name the object, do a quick sketch of what the object looks like before it moves, describe its movement. Is it fast, slow? Is it moving back and forth? The direction it's moving in. And then now they're starting to get ready for our unit, which is what started the movement. Okay, so some might be pushes and pulls, but they might not kind of put that all together. So you're gonna get some different ones. So what you're gonna do is pull them back into the class, and they'll share that with you. Now, this is how I did this. I would intentionally leave the columns blank, but I'd be sorting them in my mind. The pushes on one side, the pulls on the other, like caught the ball is pulling it towards you. But I don't tell them that, because we're going to work through pushes and pulls, and they're going to come back to these movements and classify and label the sort. Okay. So I always end my lessons like, okay, we're going to move on. We're done movement, with some I wonder questions. I wonder questions provide insight into ideas that students may be wrestling with, and also they provide really good questions you can pull for investigations, because they're supposed to be developing questions for the purpose of an investigation or further investigations in grade 3. So I'm going to just walk through lesson 1 at the beginning of lesson 1 here today. And there's more days, but I don't think I'll have time to kind of go through that. But this is the launch into the whole idea about conducting an investigation. So if you did the ice cream unit, I had learning summary tables. This is in that research as well. So basically what it is, and if you don't have room in your classroom, you can use a Google slide. I have an example of that here, but you have to bring it up at the end of the concept. So basically what they do is they have their driving question, and they're doing the small investigations along the way to learn to find answers to those bigger questions, like how do we get a soccer ball to start moving, change speed and direction to score a goal? So they're going to make observations. This is my own classroom. This is an example of mine, what they've learned. How does it help us answer that question? Okay, so they're thinking and synthesizing along the way. I always add vocabulary, or I have I wonder questions for you guys. There's different examples of these, but they're really allowing students to socially to construct their conclusions and help each other. You can get them to write their own after, but this is a nice way for them to do some think, pair, share about what they've learned to consolidate their learning. Okay, so in day 1 in the launch, this is the launch of the big investigation, the whole kind of the summative piece as well. So last lesson, you might say something like, and you can look at the questions, and maybe that some student came up with, what starts movement, or what changes, how do we change things that are moving? They may or may not, or you can put yourself in as an example, but you might say something like, last lesson, you observed the objects on the playground that were moving and how they started to move. And Johnny was wondering, or I was wondering, what makes things start to move or change direction? Let's think about that. Let's look at this ball on the table. How could we get this moving? And they might say, I might kick. Well, what would you use to kick? Oh, with my foot. Or I might, and you kind of get them to come up with some ideas. And then the students will watch. If it's the first couple of minutes, this is a soccer tournament. I would start at about 6, because They start the ball moving, they know that, they're gonna come with some idea, but then they're gonna see this boy score a goal. So they can kind of talk about that a little bit more, and then individually they go off and draw what they think is causing not only the starting of the movement, but the changing of the direction of the ball. And then, there's some questions that they can answer as well. Then I bring back, so now we're going into day 2. I'm going to start the investigation and answering that question along the way, but I have just-in-time vocabulary. So I've been sort of stressing this explore before explain, but in order for them to start describing and moving forward than just saying it started, they're gonna need to know what a push-pull is. I'm not introducing force yet. I want to know my students are clear on push and pulls before I bring in force. And so then they know when I talk about a force as a push pull, they know what that means. So what will make the chair, or you can use your own chair, or you can put up a picture of a grocery cart. What's going to make it start moving? Would this start to move, and then they can give some ideas, and the wheels make it move. Well, what's going to make the wheels move, right? So getting them starting to think about that. And then, or I could move it backwards. Okay, could you explain, how would you get it to move backwards? And so eventually they're going to get to that point, and you can introduce the vocabulary and bring up that T-chart about pushing and what it means. You can either put it up on your word wall, or they can enter it into their glossary on what a pull is as well. And then they can go back and tell you on this T-chart which one's a push and which one's a pull. Then what they're going to do is some hands-on investigation. So you get a bag or basket of objects, and I've suggested some, and it really doesn't matter, like string and elastic, lots of different things that move, that can interact with each other. That's all it is. So they can predict before they make their movements, and then they're going to observe. So you want to encourage, of course, we're working on that accuracy of, like, you kind of zero in on certain skills and procedures in each unit. So I'm focusing on that. So how, labeling their recording of their observations. So in here, it's like I'm going to use this picture as an example. We use the string to move the ball. And then they can draw a picture, what action. So then they should start putting in pushes and pulls using the science vocabulary. So then again, that could be your formative assessment piece. If they, then you can go to your learning summary table. So up here is their ideas of what started the movement of the ball, that lesson that we talked about, and their ideas about changing direction. Down here is the small scale investigation. What did we observe? So always get them to describe, because what students tend to do, and all people tend to do this, is jump to conclude, like the inferencing. So slow them down and say, okay, what exactly did you do to the ball? I pushed it with, I kicked it. Okay, let's use some science terms. I pushed it, then it moved forward, or I pulled it. Then what do we learn from this? Well, objects need people or other objects. Hopefully they're interacting with other objects and making the other objects move the other objects, as I mentioned, to start movement. Objects do not move on their own. Okay, so that's their drawing of a conclusion. And then how does this help us with about, starting a soccer ball to move, or changing the speed and direction of the soccer ball? Well, to start it, we need the moving, we needed to kick a push, right? So as they go through these lessons, they're going to kind of start building up some of that criteria and some of their understanding for that summative task. So you're not just throwing it at them at the end when they get to that point. As I mentioned, I put I wonder questions, but if you choose, you can put science vocabulary there instead. That's completely your call. So if your students need more practice, this is when I would do the sorts. because I've seen them all over and people connecting it to our curriculum. I wouldn't start with push-pull sorts like this or anything. After, you are observing, you're hearing, you're listening. So this is linked, this resource. So it has like the mat. And what I liked about it is that some items like a broom is both a push and a pull. So getting them to think about that as well. And I also liked it because it's kind of, inclusive. So here are like, there's more than this listed, that they can get phrases that they read with partners, or they can get a phrase with a picture. And then there's blank ones that you can actually add pictures to. I thought this was more of a useful resource for you to use. So that is the start of lesson 1. There you have way more days. That is about 2 days I just showed you, but you do have 3 or so days more. I do go through how I would guide students in terms of describing the strength and direction, as I mentioned, with using arrows. So I kind of have a lesson with that. And then I have my lesson ideas. Okay, so that gets you started for today, but I do hope that some of the key ideas that you take with you going forward is that the science methods are meant to be integrated into all other organizing ideas. And they are, Taylor, I'm going to get to your question for sure. Secondly, they're the way in which students should be building knowledge. So I hope you see today that these are the ways we can get them towards push and pull, and then eventually get them to force in the next consequence lessons. And then for teacher clarity, taking the time to unpack the curriculum empowers you to be the professional to choose activities and resources that truly align with our curriculum and what it means. The learning sequence is a flow. So where am I going? How am I going to map this out? And where am I bringing those scientific methods in? And the planning resource that you'll receive today as well. So the sorts and all of the resources are linked. So I'm going to share that with you. That is down here. So okay, so I just want to point out again that you are going to get this PDF, but the resources for the sample unit today are all linked in that document I showed you. And that is on step 4, right here, where it says sample plan. I walked through that sample plan. So even the sorts and everything is linked in that particular lesson as well. So I'm going to share this in the chat. It may open up in another tab. So, because sometimes people were mentioning that. And then I'm also just going to skip the move because you came live today. I'm going to give you a forced copy of the sample unit, because when you open the link, it makes a forced copy for you so that if you want to edit or change or add to it, you may. Okay, do that. And there you go. So I'm going to stop recording. And if you have any questions, feel free to ask them. Recording still happening.